Hi guys, in this video we're going to learn how to find the area of a trapezoid. So the shape you see on your screen right now is a trapezoid. The way we define it is that it's a quadrilateral, meaning it has four sides, and it has one set of parallel sides. And just keep in mind that for two lines to be parallel, they run side by side forever and ever without meeting each other. So your formula for the area of a trapezoid is right here. This is really important to write down. So the capital A stands for area equals 1/2. You're multiplying it by the height, and then you're multiplying by the sum of the bases. So the trickiest part to trapezoids is identifying where the bases are, and the trick is you're looking for your parallel lines. So in this right here, I've highlighted them for you because these two lines are parallel, those are your bases. It doesn't really matter what you identify as base 1 versus base 2. You're simply going to substitute the numbers in either order, and then we follow PEMDAS to actually solve that equation. So I'm going to grab a highlighter here, and the first thing I'm going to do is find my bases for this first example. And I'm looking for two sides that are parallel, so that would be this right-hand side and this left-hand side. Now, based on the fact that those are my bases, I also need to find my height. And you always want to use a line that is straight for your height. So that would leave me with the 15, which means that this 15.8 is actually extra information. You really don't even have to worry about it. Once you've identified all of your pieces, the first step that you're going to follow, you're going to copy down your formula. Next up, you're going to substitute in each of the things you know. So we identified the 15 as the height, and then we identified the 8.5 and the 13.5 as the bases. And then finally, you're going to solve that either mentally or in your calculator. You're going to get your answer, and then you're going to label it with the unit of measurement, but it's always going to be square units because it's area. Here are two more examples. So again, I'm going to grab my highlighter first, and I'm going to identify all my parts. So in example A here, my bases are my parallel lines, so the 6 meter side and then the 9.5 meter side. And you're going to notice sometimes both sides of the trapezoid are slanted, which means they're not giving you a height measurement. And in that case, they'll give you this dotted line in the middle of the shape. So there's my height. So now again, just like before, we are going to start off by writing down our formula, and then I'm going to fill in the numbers I know. So the height is 4.4, the bases are 6 and 9.5. Again, if you flipped these bases around and did 9.5 plus 6, the commutative property proves to you that it will not matter. And then you're going to go ahead and solve that and label it square meters. Our final example here, to identify my parts, I'm starting with the parallel sides, which are 21 and 6. And this is another example where they give the height inside the shape with that dotted line running up and down. So we'll write down our formula and we sub in what we know. The height is 6, the bases are 6 and 21. Follow order of operations and you get 81 square meters.